like on air.
Okay.
So sorry, I should have started it 17 minutes ago, but
That's okay. That's okay. At least
well,
we
I
got.
forgot how to post it. It took me 20 minutes to figure out how to post it.
Oh, darn it. And I've never done that, so maybe one day I should try it just to see
Yeah,
if I
just in
can
case you
figure
had
it
to
out.
do it in another class or something that you'll know how.
Yeah, exactly.
All right. So hopefully I have my, I was going to open my Excel things on the bottom just so I have them open. So I'm not chasing them all down.
Do you have a bird?
Me? I
Yeah.
do. I do.
Okay.
And he's right beside me. So he
Okay.
is chirping. His name is Chirpy.
Oh, cute.
Well, we had two, however, um, the other one died like a year ago, so we only have the one.
Oh.
But he has plenty of water and food. Usually he chirps at me if he doesn't, but it looks like he does. So
He just wants to help us with our math.
he's usually quiet at this time, so he's
No, he's like a
okay.
kid. You know, when you get on the phone, they always want to talk to you.
I know.
Bird's the same way. I'm trying to get my Excel to work. I'm having issues here.
Well, I have mine open now, but I don't know why I still have one screen, and that was last week's, so I don't need it. But I have freshman and the dentist, so I have the two for this time.
Yeah, I'm opening those right now.
Just because I had so much trouble with it on Tuesday, I thought I'd try to open it. We were booed. Somebody brought us a bag of treats and rang the doorbell. That's why the dogs were barking earlier.
Aww.
So it's just a little thing that says you've been booed, and it's got a bag full of candy.
Oh, how
That's
cute.
nice.
And then what you're supposed to do is make a copy of the boo and then go boo somebody else. So.
That's nice.
And then you put the note on your door that so they know you've already been booed, so you don't get booed a lot.
Boo, boo, boo. That's fun.
Okay, I've got everything up now. Finally. I think. Let's see. Okay, I'm good to go. Okay, so when calculating anything, please remember to round to 3 decimals. Do not round until calculation. Okay, so what requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all that apply.
Well, it has to have a normal distribution, I thought.
It does have to have, yeah, it has to be normally distributed.
Sample size must be the same.
For each group?
Two means with independent.
Right, I think I need to pull up the textbook.
Yes.
This is not a good sign.
No. And I still have to finish that darn final paper for my other class. I still haven't finished it.
Oh, no, is it due today?
Tomorrow.
Tomorrow it should be.
So I have to buckle down and write a whole bunch of paragraphs.
Sorry.
You'll get there.
I know. It's like, I keep thinking it's worth 30% of my grade, but my other things were worth more than that. So what Is it really going to hurt me if I have a 98?
No.
so,
But you still want to do the best you can do, you know, just in case.
yes.
You really,
Okay, give me the pep talk. I need it.
yeah, you still want to do your best.
You say that, but I get to the point where I'm like, that was good enough. Good enough.
Oh,
You need to dig deep there, Lydia.
Yeah, I know. Always
deep.
deeper. I can't push the buttons any further down. That's deep as they go.
That's funny. Okay, so we're let me see. Let's see.
It's independent samples, right?
and yeah, that's what I wanted to make sure. What
Okay, there's
requirements
no
must be
pairing.
conducted when two means with independent samples?
Okay, so there's no pairing between the groups. Suppose you want to compare the incomes of men and women in general population. A random sample of men would be collected, and each would be asked to report their income. Similarly, a random sample of women would be drawn, and they would also be asked to report their income. Notice that the groups are independent.
But it says what requirements must be checked when conducting a hypothesis. So
This is for 13, right?
this is for 3.
Yes.
No, I mean chapter 13, sorry.
Chapter
Yeah,
13.
And I was reading what you were reading,
So was I.
but I just don't see what the answer is.
It does say a random sample needs to be collected. Suppose you want to compare the incomes of men and women in the general population. A random sample of men should be collected, and each would be asked to report their income. Similarly, a random sample of women would be drawn, and they would be asked to report their income. Notice that the groups are independent. Knowing the names of the men who were collected tells you nothing about which women would be selected. So a random sample needs to be drawn from each population.
That's the first one. We don't have mu is greater than 0 though.
No. And the sample size must be complete. It must be the same for each group. That doesn't matter, not for an independent.
Nope.
Because they're not paired.
So it would
But
just
do
be.
they need to be normally distributed though?
I don't know where I read that. It might have been on the video I watched.
Yeah, that's what I was trying to remember also in the video.
Oh, let me take a look.
Because there was a video in our lesson that other instructor.
Yeah, that kid that looks like he's 12.
Yeah.
The kid.
The kid, exactly. Okay, so what's the difference between matched paired data and independent samples? The numbers in the rows are matched.
Okay, here I found it. Step 4. There are 2 requirements that need to be checked when conducting a hypothesis test for 2 means.
Yeah.
And that says the random sample size is drawn from each of the populations, and X is normally distributed for each group.
There it is.
Boom. Perfect. Thank you. And you saw that where on 4?
That's
Step
on
4.
the bottom, step 4.
4-1.
It just says step 4 and has an M next to it. So it's under 3 where it says hypothesis test.
Okay.
It's like at the very beginning.
Okay.
This is step 1, step 2, step 3, and then it shows some graphs, and then step 4. Verify the requirements have been met.
Awesome. I see it. Thank you.
Yeah, I remember watching it on that video.
See, and I saw that video, and so that's why I was like, I think that does look right, but where is it? Okay, so then I went further down. The next one's going to be T, because it has the test is statistic. T is given And still E23, it's in the Excel instructions under hypothesis test. Because it has T and it has DF for the degrees of freedom.
Yeah. So it's T-scores. What's an F statistic? I don't remember seeing that. Did I miss that?
I started talking about it in the video. But then he said, or any variable you want to give it. I'm like, no, don't do that.
Don't do that.
That's too vague for me.
That's like learning algebra and, 1 plus X equals C or whatever. It's like, you can make it any variable you want. It's like, don't tell me that.
Yeah, I don't get it.
Okay, so number 5, 2 samples are independent if knowing which subjects will be in group 1 determines which subjects will be in group 2. And that is not true, right?
Right.
Because it doesn't matter what's in group 1 or group 2. Knowing which subjects will be in group 1 tells you nothing about which subjects will be in group 2.
Yep.
Yep.
Yes, agree?
Yep. Because it's not paired. Okay, next 6 questions.
The next 6.
Dennis.
Do you guys see that? Do you see what they did to us? It's now 18 questions to answer. I think they keep, upping it.
It's crazy.
No, I think last time we had 19.
We did. We have 2, I think, 18 or 19. We have 2 less this time. Okay, for the next 6, we're going to use the dentist office bills. The data represents a simple random sample of dental bills at a dentist office in Idaho Falls and the dentist office in Rexburg. Let U1, I got to write it down, be the mean for the Idaho Falls. And let U2 equal the Rexburg. Perform a hypothesis test to determine if the mean bill at Idaho Falls office is less than the mean bill in Rexburg.
Okay, so we're going to use the
2 sample or the paired sample?
No, they're independent of each other, right?
So it's the 2 sample test.
It's a 2 sample test. We're just going to see what each office has and then answer.
And it's the 10%. Okay, so let's get that plugged in.
So, well, the hypothesis, let's make sure, because which mean for the Idaho Fall, if perform a hypothesis test to determine if the mean bill at the Idaho Fall office is less. So we have UA is less than
Variable A is less than variable
U2.
So I have N as 20 because there should be 20. Is there 20? There should be 20.
Yeah, N is 20.
And
what's your T-score? Is it minus 0.42?
So the degrees of freedom would be 19. That's always N minus 1.
Right. Okay. That's right.
I clicked the wrong one.
We want 3 decimal points. Don't forget those 3 zeros at the end.
On the degrees of freedom?
Yeah, it says round to 3 decimal places.
Did you get the other app to put these in?
Yeah, it's the quantitative
inference procedures. Are we doing not equal? We're doing not equal to. No, wait a second.
What does it say?
Is Idaho Falls less than Rexburg?
And it's the 10%, so that's got to change it from 95.
95 and it's 0 null hypothesis and then less than
90%. Because 0.05 is 95%.
Oh yeah, okay.
So this is 90.
But it's still less than the type of test, right?
Yes.
So it's 19. It's still 19. But
not even
that
there.
will always be 19. Because N's always 20 on this.
Yeah.
The only thing it changes is like the p-value.
Yeah.
So you're putting this in the one and the t-stat, the one sample, correct?
The 2-sample t-test.
The pair, 2 sample, there it is.
Because we did paired last on Tuesday.
Right. Hang on, I gotta now copy you guys are way ahead of me. For some reason, I didn't have that other app open. Copy.
Oh, wow. Something just happened here.
Paste.
That's weird.
It didn't work. Well, it's all blue. It won't paste. Copy.
Okay, wait. Is this one, so we've always been told degree of freedom is n-1, but it has on the 2-sample t-test, a DF is 37.996. So that would make sense for the 3 decimal places instead of it being 19.
Okay.
Okay, my degrees of freedom right now. Okay, this did not, it's not taking it. I'm getting a bunch of reference.
Now let me make sure I put them in the right order.
I got it. I got it.
Idaho and then Rexburg. Okay. So I think I've caught up now. We got N of 20, a mean of 260 and 288, a degree of freedom of 37.996.
Yep.
Okay, I just want to make sure I got to the right place. So degree of freedom, 37.996.
Oh.
What is the sample standard deviation?
That should be the 37.
For Rexburg.
For
what did you say it was?
37.996. It's next to the T. It says DF.
Oh, I already got that. I was on 7. The sample standard deviation of Rexburg.
Yeah, we haven't started that yet.
Okay.
And that is the first variable, so that should be 208.875. Nope, it should be 206.637.
Right, 208.875 for. Oh no,
Idaho
that's for Idaho Falls. Rexburg is 206.637.
Right.
So wait, is Rexburg variable 1 or 2?
Rexburg is variable 2.
Okay.
What is the test statistic?
Which is minus 0.434.
Minus point.
Which one is that one? Where's that at?
The T-score.
It's your T-score.
Did you guys have negative?
Yeah, I have negative.
Okay.
Do you not have negative?
I do. I just wanted to make sure.
Yeah, it's negative.
And then what is the p-value? 3 decimals, 0.333.
Yep.
Wait, I have 666.
Okay.
Do you have the confidence interval changed to 0.9?
Yes.
And then the test type is
Not
less
equal
than?
to. Oh, let me change that. Okay. There we go.
You got 0.33327 da 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 da.
Yes.
Okay, and then we have to fail to reject the null because it's higher than the confidence interval.
Correct.
Or higher than the A. I'm sorry, higher than alpha. Right?
Yes.
It's higher than the 0.1.
Right. So we fail to reject that.
I ate it.
Maybe we understood this a little better. Or this is what I was expecting last week, because this is what we did on the homework. So this is what I was expecting, not what we did last week.
Yeah, that was a nightmare.
Not the crazy.
Hey, we're
Okay,
we're already on question 10. This is 11.
We're on 11.
Don't say that.
I'm
Don't
sorry,
talk about the
sorry.
number. I'm just
So
kidding.
now we're gonna change this to, but now we're gonna change this to not equal,
The mu1 not equal to, no.
not equal to.
Right. And
Hey,
is it
baby.
still 0.90 though? Let's see.
I gotta get a hug
I
from
don't
my
think that
granddaughter.
changed. I think it's just not equal to.
Okay.
It was good, thank you. How was your day? Good? Okay.
Good.
You do my homework, okay?
Hi.
Say hi.
Hi.
She's like, what's
Hi.
going on?
Okay. See you later. She asked me how my day was. How was your day at work?
Aw.
Okay, moving on, back to 11, sorry. I needed the little love.
Yes.
Well, 11. Okay, so suppose instead that you had used the alternative hypothesis, HA, mu1 is not equal to mu2. What is the correct decision based on this evidence?
So do not equal to, right?
Not equal to.
Is not equal.
So do we have sufficient evidence that the mean dentist bills between the two cities are different?
And we have, it goes, the p-value goes up to the point, the 6.
0.666.
0.66.
Yep. Do we have insufficient evidence that the mean dentist bills between these two cities are different? The means didn't change. So do we have sufficient evidence that the mean dentist bills between the two cities are the same? They are the same, aren't they? Or do we have insufficient evidence that the mean dentist bills between the two cities are the same? Because if you change it to less than, the mean doesn't change at all.
No, it doesn't. It's just the p-value that changes.
Right. But it's asking about the mean. We had one of these questions in the last test too. Is that somebody trying to call in?
No, that's just my texting. Sorry.
Oh, okay.
It just changes that p-value. Like
Yeah, I'm
doubles
trying
it.
to look at the preparation assignment to see.
I think, so the probability of 0.666 is a high probability, right? And the difference, but the mean, one is 260 and the other is 288, so they're not the same.
No.
But they're the same as they were before. So what are they asking?
But we're asking, they're asking if it's not equal to.
That's true.
It's not
So-
equal.
So we have sufficient evidence then that the mean dentist bills between the two cities are different.
Yes.
I
So it's
believe
option
so.
A.
That's what I
Okay.
believe. And I could be wrong. Okay, now we get to go to freshman dinners.
Great.
Yep.
So let me click on freshman dinners and change my numbers.
Are we using the same one, right? The same
Yeah,
format. All right,
Well,
so A will be Utah and B will be Colorado. Or two. One will be Utah. Two will be Colorado.
I'm gonna delete
Do you
all
see
these
where
totals.
Utah's has one longer than, or two longer than
yeah,
Colorado?
which means that it's not a paired test, that this is
Right.
an independent test. I feel a lot better this week.
No, just today.
Just today, yeah, that's true. That is true.
I just want us to be able to take all the tests together. We'd be fine. Get,
I
I
know.
know.
I wish we could help each other with the homework quizzes too, because that's where I struggle.
we don't have somebody bouncing ideas
I
off
wish
each
we
other.
could take the finals together. I think that would be way better.
So
Be successful.
my question, I guess my question would be, is back up at the top when we were deciding number, oh, we said requirements for 2 means, never mind, the sample size must be the same. What was, never mind. I thought there was a question about them being not equal in number.
They don't have to be equal if they're independent, but they do have to be equal if they're paired.
Right. Okay, so let me
And it
write this
doesn't
in.
matter what order the variables are in, whereas if they're paired, it does. You have to go straight across. You have to stay in the same row.
Yeah.
Okay.
Okay, so 12. You see the
Yep.
null? We just have to do the alternative hypothesis, which would be not, because that one's equal to. Right?
So, oh, I didn't finish reading it. I just wrote down what I needed, got everything plugged in.
So the
You
mean,
suspect
yeah,
the freshmen from Utah cook dinners themselves at different number of times than freshmen in Colorado. Perform a hypothesis test to determine if your suspicion is correct. You suspect that freshmen from Utah cook dinners for themselves a different number of times than freshmen, but it doesn't say more or less.
No, it just has just the null hypothesis is,
Yeah.
and then use the 95% in the confidence level.
Right,
level.
so
But
I'll
it's just
change
asking
that.
what the alternative hypothesis would be. And wouldn't that just be the not equal to? Because it's going to
Yeah,
be the
because
opposite.
the means
I
are
agree.
different.
Correct.
Okay, 13. What is the test statistic?
0.845.
0.845. What is the p-value? 0.411.
0.411. Because you're going to
Yep,
round up.
right.
411, information.
Yep.
And what decision do you make?
We failed. Let me see. Let's see.
0.1.
Fail. Because look at the means.
P-value was 4.1 and we failed to reject it because it's higher.
Yeah. See, you guys
'Cause our
laugh.
p-value
My
is-
girls are over here just shaking their head at me.
Because we had an alpha of 0.05. Our p-value is 0.41, so we have to fail to reject it,
Right,
right?
because it's high.
Yes.
Okay. Okay, determine a 95% confidence interval for mu1 minus mu2, an estimate for the difference between mu1 and mu2. Input your answers below. So this is a margin of error of 95, confidence interval. Okay, so we have to subtract those two, don't we?
Correct. To come up with,
So
With whatever they want there.
we're looking at the means, right?
no, we're
the
looking at the confidence interval.
So you can do it either way, minus 2.214. 2.214 minus 5.4147. So I get minus 7.361.
Me too.
Let's see if it
But
works
that
the other
doesn't
way.
seem right.
Yeah, it does, because one's a positive number, and you have to subtract it. Let's see if it works the other way.
Because I did negative 2.214 minus 5.147. I got negative 7.361.
Right. Yep.
Correct.
And you actually can't do it the other way unless they're both negative or they're both positive, right?
Well, it just comes up a positive answer if you take 5147 and minus the negative 2.214. It
Right.
becomes positive 7.3.
So we're going to say minus 7.361.
Yeah.
Correct.
You shut the door, Rena.
Okay, input the
What
lower
was the low bound?
minus 2.214
Negative
2.214.
2.214.
and the upper
And the
bound
upper
is
bound,
1.147.
147.
Whoop
Oh
whoop!
my gosh, ladies.
Oh my goodness, what is going on? They needed to throw that at us because I was getting ready to just scream.
Yes.
Now, hopefully, when we submit this, it all comes out wonderful.
I know, that's the second part now.
I know,
It just feels too real, too good to be true.
I know. But guess what, ladies? Oh,
Did
we
we get
missed one. We
That's
missed
okay.
11, and we missed 13,
We missed
and we
11?
missed 16, and 17, and 18.
Oh, gosh.
No! How can that be?
Because it was too good to be true.
The answer
Okay.
is SPSS is slightly lower than in Excel, so the answer given is the average between two results. Your result should be close to the answer shown. That's for 18, because it has like should view feedback.
Okay, I'm going back up to the top for a second.
That doesn't make sense.
So we missed 11, 13, 16, 17, and 18.
Yes.
All right, that sucks. Okay, let's go back to 11 then. Ah.
At least we got 3 right.
Oh, see, I started writing the answers in the wrong place again. I was going to mess up my whole test.
I did the same thing as you yesterday. I wrote one down wrong.
So 11 we got wrong,
Yeah, it's not A.
and 12.
It's nothing. What else isn't it?
I know. Can you tell us what else it isn't? Tell us what it is.
13 we got wrong, 14 we got right. 15 we got right.
Got 16 wrong.
Because of this minus.
And 17 wrong.
So this is saying it wanted an estimate for the difference between the two. So should we have added and then divided by 2?
No, because it's a two-tailed test. It's not a one-tailed test. If it were a one-tailed test, we would have to divide by 2.
Well, it said, because it said an estimate for the difference between mu1 and mu2. And it's saying that our answer should be close to the answer shown. Our result should be close to the answer shown. Because when you click on view feedback,
Where'd you get view feedback?
it's showing on my meeting quiz.
Oh. Let's see.
So on each question, I have view feedback underneath it. And we're using
Oh,
it.
I see. It says view feedback. I see it.
Okay, so let's see.
So average between the two results.
What number are you guys working on?
That's
You
six,
working
I was
16.
16.
16? Okay.
So the answer given is the average between the two results. Oh, between Excel and SP, whatever. I don't even know that other one.
SPSS is another program, a spreadsheet program like Excel.
Are we still doing the not equal to?
Yeah, because it's two-tailed.
Right.
This is the same question I missed on last week. Determine the margin of error for a 95% confidence error.
Do we need to use the applet?
Oh.
So then 0.845.
845, yeah.
This is
With, what is
Oh,
the
I get
degrees of
0.4602.
freedom? Do we do the degrees of freedom though? 16.562.
562. So 0.4102.
For which one? For 16?
Yeah.
Yeah. What do you think?
so you put the degree of freedom
Yeah.
and then the error, the T-score down at the bottom, right?
Yeah.
And is it the same thing that Jeremy talked about last week where he added the 2 and divided? So it'd be the 0.845. Was it 0.845 plus 845?
I missed
that how
that
you-
even after he told us how to do that. So I did it wrong.
Well, and then I'm wondering for the lower bound, is it negative 0.845 and then it's positive 0.845? And then the answer is 0.4102 for
That's
16.
That's what I got is 0.4102 because I put in 0.845.
Me too. 0.4102.
0.4102 is what I
So
get.
just be 0.410.
And we got the confidence interval right. We got not equal to.
That one's the second one.
Okay.
Not that one.
So are we using the lower bound then as the same as the upper bound, the 0.8, the negative 0.8145?
I don't get this. I mean, if the lower bound, because we usually take these from the confidence interval right from the spreadsheet.
Right.
So if those are wrong, then maybe we've got everything else wrong.
But I mean, at the top of the quiz, it has the students' T probabilities. So we must have to use it at some point. Otherwise, it wouldn't have been in the beginning of the test. The T distribution applet.
Right, but what I'm saying is if we're getting the confidence interval questions wrong, 17 and 18 should be just easy fill-in questions. If those are wrong, maybe something's wrong in the actual spreadsheet. 95% confidence interval. Estimate the difference. Estimate the difference between mu1 and mu2. Okay, so wait a second. It says estimate the difference between the means. So do we take the means and subtract one from the other?
Wait, it's the margin of error. What is the margin of error equation that we had?
It's mu1 is not equal to
Because we did it in 12. Was it 12? What one did we do? Mean, what was it? Because this one has that.
1.467.
It's that margin of error. We need to get the margin of error.
So what's the standard
Equation.
margin of error that's always on the very end where we have n mean, standard deviation, and the standard error of mean?
I'm going to look this up.
Look in lesson 11, they have margin of error. So lesson 11, 10 also has margin of error. You're sure?
I do know I can do it tomorrow.
Okay, shut the door.
Do we have the right one? We're using the freshman students right now, right?
Yes.
Okay.
Okay, so let me just read this and see if this pertains. Because in step 5, present your observation in English. It talks about one of the things that it just did. It says,
Here's one that has the margin of error is m equals, so it'd be t score times the mu divided by the square root of n. Does that sound?
Okay, so it would be
say it again.
0.45.
So m equals t times the mu, the mean,
By the
divided
square of
by
n.
the root of n.
Do we have to do that for both means then?
I don't know. That's what I'm wondering, because it's like an average.
Okay, this is not right. Oh. We're doing something wrong in the beginning here.
Okay, I'm going to go back to the lesson, the very last question. Let me go back there.
Here's something interesting. Finding the margin of error for both of them. One is 4.066, the other is 4.062. Which I think is very interesting to be so close.
Do we have to take the confidence interval and times it by, let's see.
Let me go back and
I
read
think
our
the margin of
question
error
now.
is the t-score divided by 2 times standard deviation.
Yeah, even in the assignment, nowhere does it say
Or
how to calculate this. It tells us how to create a 90% confidence interval for the difference in the mean responses of two groups,
we need the margin of error.
but nothing does it say about the margin of error.
Do we have this written someplace else, like on our?
On one of your
In
stickies?
chapter 10, yeah, I have it on sticky, but on chapter 10 I had the margin of error. 11 talks about margin of error. Now
So
this right here has confidence interval, but it's like paste column B, paste columns A into the desired confidence level. We did that. Confidence level interval will be given in the two cells. That's for the 95%.
I knew it was too good to be true. So
And so,
should this be less than, you guys? Because it says determine 95% confidence interval for mu1 minus mu2. So should that not be equal to? It should be less than? It only changes the p-value, but
Did you say less than?
should it be? Because it says mu1 minus mu2
I know, but we're also trying to get the 95.
percent confidence interval.
so, okay. So tell me, just remind me, when we're on the student T probability, and we put, the degrees of freedom, the 16.562, and then if we
Yep.
say the area is 95,
Well, you have to put the t-value in to get the area.
no, you don't. It'll give you the T value.
Right.
If you put in the degrees of freedom and then you put 0.95 in the area, it gives you then the T's.
Yes. And we need to find margin of error. But I'm just looking at, like I said, I did the M equals T. I
Me
did the two
too.
different means, and they're very close, like 4.066, and then the other one's 4.062.
Correct.
I get 410.
So it would be 0.004 would be the difference, right?
Yeah.
Oh,
What was the question now? I get on a tirade and then I can't remember what the question was.
determine the 95% CI for mu1 minus mu2 and estimate for the difference between mu1 and mu2. Input your answer below.
What was it back? Let me see. Let's scroll back a little bit. Because the confidence interval, if we did that, you remember it was X plus or minus.
Divided by, like the mean minus the mu divided by,
X minus Z divided by sigma over n squared.
yes.
But that gave us our confidence interval.
Because of the plus and minus.
Right. Which margin of error? Margin of error, M equals Z times sigma over n squared.
Yes.
So the Z,
Because that can be T.
0.845.
and that's exactly what I did. So Determine a confidence interval and estimate the difference between.
Hey, for the area, on the T probability, could we put 0.95?
Repeat that. Sorry, I didn't hear you.
So the T probability applet
Yep.
for the area, can we put 0.95?
Yes.
Because one time we needed to do that and it was something simple.
I know that's what I was trying to remember because then it gives me negative 2.114 and positive 2114.
What do you have for the degrees of freedom?
16.562.
And then I put, see, because I put 0.95 in the area and I have 0.064.
What do you have as a degree of freedom?
The 16.562.
Same here, and then the area 0.95.
Yeah.
And I'm not
And
getting.
then you have the green. You have the green highlighted or the tails highlighted.
The tails.
Okay, so if I highlight the tails, it's negative 2.114 and positive
area?
214.
I get
Put 0.95
Oh
in the
no, it
area.
changed the area. It changed the area.
It's
Oh,
0.064, isn't it?
0.064.
Yeah. As a T value.
How does that change U1 minus U2?
I don't know. I'm just trying to think of what we've done in the past and see if it applies to this.
Yeah. I think we do have to find something divided by 2.
Hmm. Okay, what were the other questions? Let's take a break from that for a minute.
Well, the other 3 are kind of, the other 2 are contingent upon whether we do that.
What do we do with
The
number
lower bound
11?
and the higher bound.
Yeah, the
Or
lower
what'd we
bound and
do?
the upper bound. I don't know why that's not.
Because we just took the confidence interval, which is what it should be.
Right.
Yeah.
Okay, let's look at 13.
I know, I decided, let's go back up and find the one we.
The test statistic, we got that wrong, didn't we?
Yes.
0.845 is what I have.
We did T.
Yeah.
Let's try not equal to.
It's the same. The only thing that changes is the p-value.
Yeah, the only thing that changes is the P. Well, it doesn't make sense because our p-value, oh, it didn't ask us our p-value.
No.
So let's go back up. We got 95% confidence. Colorado is U1. Let's make sure I got those right values. Colorado is, oh, you know what? I think we have them in backwards.
It doesn't
Hang on.
matter because they're independent studies.
Right. That wouldn't, yeah, shouldn't matter.
I'm gonna verify that.
If they were paired, it would matter.
I'm just curious. Oh, sure. Now I just botched up my whole
So the
thing.
margin of error is the critical value times the standard deviation. Was this a question on preparation assignment?
No.
It wasn't, was it?
No.
Okay, so I took the p-value and I put it into the area for 13. And I got like the t-value of 0.551. Could that be the t-value?
I don't know.
Because I just put 0.4107 for the 95 percentile of not equal to, because that's what changed was the p-value.
But you know, when I put variable 1 as Colorado and variable 2 as freshman, the numbers do change. All the numbers change.
Why would they do that? Why would they switch the
I don't know. Let me
variable
make sure I got all the right numbers. Let me
Because if we put, are we supposed to put A inside of 1 and column B inside of column 2?
Well, I just decided that Colorado was 1. Come on, you stupid machine. Do what I want. I'm going to copy. Let me make sure I didn't have too many. I emptied out so I made sure I didn't, put too many letters in or too many numbers in. But no, it's still negative 0.845. Sorry, I must have hit one number too many, so it changed it.
But that's what I'm wondering, because it went from, did we have like, what was it? Where is it? Because we have it to not equal to. It got changed not equal to from less than.
Yeah, because what
So
this did was
it's not
it changed the confidence. It turned it around by putting them in the order that it said on the thing. So the confidence interval would have been a negative 5.147 minus 2.214, which still is a negative 7.316. Isn't that what we put?
But here we started off with this being less than, and then it got flipped to not equal to. Oh wait, no. Nope. That's freshman dinner.
I'm not going to Grandma.
That's why I was wondering about that point, the p-value being 0.1407, and plugging that into the probability. You just highlight the middle, and then it shows the t-value of being 0.551.
So do you think that's what we should be using instead of the 0.845?
Yes.
How did you get that?
So I went to that student t probability, that applet.
Right.
And then I clicked the middle to highlight the middle, because that's where we need to highlight. And then in the area, I put 0.4107. I kept trying to get it to change and it wouldn't until I clicked the middle and highlighted the green.
Well, I have 0.417 down below with an area of 0.318. Is that what you got?
No, because the degree of freedom, I still put in the 16.562.
Right.
And then the area I put 0.4107.
Where did you get that number?
From the p-value on the
Oh,
p-value over on the
So 0.551.
0.40, yeah, 0.551.
why did you use the p-value up in the area?
Well, that's usually what we call, that's usually what they call the p-value, is the
No,
area.
that's where we put the, okay, I see what you're saying. So you're saying it's negative 0.549.
Well, I have 0.551.
Oh, for some reason that changed.
Yeah,
In
you
the
gotta watch
area, you put 0.4107. I got 0.551.
Because when you change, yeah, so it's not equal to, that's what we're working with. But I don't know what else.
Okay.
Did he cover that in the video at all?
I don't recall. But I just keep looking at all the questions that we were in the chapter. And when it says show solution on the answer the following the questions, there's always the distribution there.
Do we have to use 95% in any of this calculation? Is that considered the critical value? I'm actually looking online to see if I can find a solution for this, apart from what we're learning in class. And it says that we can find the margin of error by taking the critical value, timesing it by the standard deviation.
What is the critical value?
95.95. But I don't remember learning about anything like that here.
We did have something like that.
Did we?
Yes, it was when we did the, we were setting up the percentiles. Was it 11? It was before we did T-scores. We were doing Z-score.
Or it could be the level of significance. So maybe it's 0.05 times. So the critical value is the point on the scale of the test statistic beyond which we reject the null hypothesis, and our critical value then is alpha, which is 0.05. And then do we times that by the standard deviation and take the difference between the two? I just don't remember anything like this.
So we all, like, here's one that has a test score, the test statistic T, calculating it by sample standard deviation.
And how did we do that? Did we times it by the
T
standard
equals
deviation?
X bar minus mu over standard deviation divided by the square root of n. But what would X bar be if we had tried that? I might. I'm gonna have to go. My battery's going to die very soon.
Okay.
Well, I went back to give the test statistic and its value. A test statistic for a test involving a paired data is T divided by, well, let's see what the 6.8 was. T equals X bar minus mu over the standard deviation divided by the square root of n.
Right.
So, because we got our test statistic wrong too, because it said it wasn't T.
Thank you.
Come on, guys.
So like confidence level 1.96. So could it be T minus the mu divided by X bar?
And then what do? Do you subtract the 2 after that? You do that for each one?
I don't know. It just keeps making me think that there's something wrong because if our test statistic isn't T, oh, see, when I put it in this way, it's a negative 8.45. Does it matter?
No, it's the same on both sides. One's positive, one's negative.
Right. I'm just wondering what he's looking for, because if I didn't set it up with Colorado as 1 and variable as 2. Okay, I'm just going to try something really quick, because I can't imagine that we did it wrong. What was 11?
Oh, what was 12? I think I messed up. That was not equal to, right?
Correct.
Okay.
What was 11? What did I get?
11 is not D.
It's not A.
11?
11 is
Yeah.
not A.
And I did D. I don't know why.
So it's not A and it's not D. That's one of the two in between.
See, we did good statistics right there.
So I'm going to say C. And what's 17 and 18? I'm going to put these other numbers. And give me, and if not, then I'm moving on because I have other homework. And not that I want a bad grade in this class, but,
Yep.
you know, we spend an hour and a half to 2 hours every time trying to do this. So,
And that's not even including the prep and then the homework and then studying for the final. And
Yep.
okay, so.
we just need more clarification, I think, because
Well, I think it's really hard because you're really teaching yourself. It's like, I'm thinking, you know, we just keep
going in
teaching.
circles. You know what I'm gonna do? I'm gonna watch another. I'm gonna watch somebody else's video and see how they figured that out.
Oh, that's
All right,
a good
guys.
idea.
I will talk to you later. My battery is dying very quickly now.
Okay. All right.
All right.
Okay.
Good luck.
We'll see you Tuesday.
Yep. Take care.
Okay. Bye.
Bye.
So Cheryl, I'm gonna watch somebody else's video.
I think I am too. I think that's a great idea.
And see if somebody else is struggling with this and how they figured it out. I have done that before but I don't do it consistently.
No, but I think because we're stuck, I think that's a good idea.
See if somebody else got the answer and how they got that answer. Maybe they're getting this margin of error that we're not getting because we missed that on the last quiz too, like you said.
Yeah. Well, okay, so I'm going to stop the broadcast.